Let's choose a theory-based hypothesis test to use with this problem. UWEC wanted to know if the average amount of sleep that students get each night is associated with the year of the student. The distribution of sleep time does not follow a normal distribution. They surveyed 55 first-year students and 55 seniors. On average, the first-year students reported that they got 7.3 hours of sleep each night, with a standard deviation of 2.34. The seniors' average was 6.3 hours, with a standard deviation of 3.6 hours. Is there evidence that students' year in school is associated with how much sleep they get? The first thing I notice about this problem is that we're testing for whether there's an association between students' year in school and how much sleep they get. That means that we should consider using a test that works with two variables, an explanatory variable and a response variable. So far, we've seen two types of tests that work for this, a two-proportion z-test and a two-sample t-test. We will see more tests of this type later this semester. To decide between these two types of tests, let's investigate what the explanatory and response variables are. Recall that the explanatory variable is the variable we think is explaining the change in the other variable. It's often the variable that's known first or that's easier to measure. The response variable is the variable we think is being impacted or changed by the explanatory variable. It's often the variable that's known second or that we'd like to predict. In this problem, it's plausible to believe that a student's year at UWEC could influence how much sleep they get. But it's a lot more convoluted to think that an amount of sleep influences how far along you are in your career at UWEC. That means that we should treat year at UWEC as the explanatory variable and amount of sleep as the response variable. Next, we want to determine the type of each of these variables. Our explanatory variable was year at UWEC. That had two possible values. All of the people surveyed were either first years or seniors. That means that this is a binary categorical variable. Binary means that not only is it categorical, but it only has two possible outcomes. When we have a binary explanatory variable, we want to consider using a two-proportion z-test or a two-sample t-test. Alternatively, we could think of year at UWEC as a quantitative variable, with the number of years a student has been at UWEC being either 1 or 4. The advantage of this would be that we could interpret the change in sleep per year a student has been at UWEC, which would let us predict the average amount of sleep for sophomores and juniors as well. Generally, we only think of a quantitative variable when there are more than two possible values for it. If we do it with only two possible values, we need to be really confident that there really is a linear relationship between the amount of sleep that first years get and the amount of sleep that seniors get. The disadvantage of treating this as a quantitative variable would also be that we would need to analyze it using linear regression, a technique that we'll learn about later in the semester. The response variable was the amount of sleep that students got, recorded in hours. That's a quantitative variable. So here we have a binary categorical explanatory variable and a quantitative response variable. So we should consider a two-sample t-test. Next, let's check the validity conditions. Recall that the validity conditions for a two-sample t-test are that each group should have a symmetric distribution, or should have a large sample size and not be strongly skewed. In this problem, we were told that the distribution of sleep time does not follow a normal distribution. That's indicating that the first criterion of a symmetric or normal distribution is not satisfied. But we're also told that they surveyed 55 first-year students and 55 seniors. So our sample sizes in each group are at least 20. 55 is enough larger than 20 that it can overcome some amount of moderate skewness. So in the absence of any information to suggest that the data would be strongly skewed, I'm willing to believe that this second criterion is satisfied, and the validity conditions overall have been met. That means that a two-sample t-test is appropriate.